Hi, my name is Yushakimi bin Jamaludin. Matrix number F2380383.
Hi, my name is Aimanul bin Dzunaidy and my matric number is F23A0812.
Hi, my name is Najihah Aziz. My metric number is F23B0475.
Hi, my name is Hanim Umaira Binti Husnee and my metric number is F23A0622.
We are going to talk about some of the problems that related in bioscience. One of the problems that related in bioscience is minimizing water usage. We know that water is very important to all living things. However, I'm going to tell you 3 interesting facts about water that you might not know yet. The first fun fact is water usage is that it takes about 2,700 liters of water to produce a single of cotton t-shirt. Secondly, you can refill an 8-ounce glass of water approximately 15,000 times for the same cost as the 6 packs of soda pop. Thirdly, a dairy cow must drink 4 gallons of water to produce 1 gallon of milk.
Water is an essential resource that has played a significant role in human civilization since we first left the oceans, from ancient civilization to modern times. The history of water usage and sanitation showcases our pursuit of clean and accessible water sources. The origin of water supply system can be traced back to ancient civilizations such as Mesopotamia, Egypt, and the Indus Valley. These early societies recognized the importance of having a reliable water source and devised innovative solutions to meet their water consumption needs. The relationship between food security and water usage has evolved over centuries. Ancient civilizations, such as those in Mesopotamia and Egypt, thrived due to their innovative irrigation system that allowed them to cultivate crops in arid regions.
Consider that water usage is a scientific matter. That water usage equation is this, and can equation of water usage turn into programming code? Yes, it can. And I will guide you and see you later.
Hi, I'm going to talk about the improvement for minimizing water usage. The improvement that we can do is reduce the use of water through switching to water-saving devices such as aerated tapes, sensor control taps, low flush toilets, or hoses with triggers that supply water only when needed rather than constantly running. If possible, use bucket of water to clean equipment rather than running water. Ensure the pipes and the taps supplying the water are maintained on a regular basis to avoid water being lost through leakage. Point number 2 is implementing water recycling techniques such as rainwater harvesting and rainwater system can significantly enhance water usage and efficiency on the farm. Rainwater harvesting involves collecting and storing rainwater from rooftops and other surfaces for irrigation purposes, reducing the reliance on groundwater and municipal water supplies.
Hi, I'm member number 1. For the first solution, for the problem how to minimize water usage, first you need to adjust the initial equation. And the first equation is Wx equal to 500 equal to plus 20x plus 0.5x squared. And the first step is use derivative the equation, which means it becomes dw over dx equal to 20 plus x. And the second step, you're setting the derivative equal to 0, and the equation will become like 20 plus 20 plus x equal to 0, and you make x as a subject, it will become x equal to negative 20. When for this problem, it can the x it can be less than 0, which means x must be more than or equal to 0. So practically, when negative 20, so you choose the 0 for the x, so x become 0. When you sub x equal to 0 into the equation, and you will get w equal to 500 plus 20 in bracket 0 plus 0.5 in bracket 0 power of 2. So the w will be equal to 500. And W is water usage for this equation. So W is the answer for this question, for this solution.
Hi, I'm member number 2. So we're going to move on to solution 2, adding realistic constraints. So the problem statement is, a farm uses water to irrigate crops and add water usage, W in liter, is given by the function. So the function is Wx equals to 500 plus 20x plus 0.5x squared, where x is the number of irrigation sessions per week. However, the farmer must irrigate at least once a week. Determine the optimal number of irrigation sessions that minimize water usage within x more than or equal 1 and less than or equal to 7. So first thing is, first we're going to get the first derivative, which is dw over dx equals to 20 plus x. So next, we're going to setting the derivative to 0. So 20 plus x equals to 0, and we get dx equals to negative 20. Second derivative test, d power of 2w over dx squared equals to 1, since the d power of 2w over dx squared more than 0. So given x more than or equal to 1 and less than or equal to 7, so we insert the 1. So w in bracket 1 equals to 500 plus 20 in bracket 1 plus 0.5 in bracket 1 squared. And we get the answer, which is 520.5 liter. Second, we're going to insert the 7 to get the answer. So W set in bracket 7 equals to 500 plus 20 in bracket 7 plus 0.5 in bracket 7 squared. And we're going to get the answer, which is 657.5 liter. So the So the conclusion here is the optimal number of irrigation session is x equals to 1 session per week, and the yield is 520.5 liter.
Hi, I'm member number 3. So this is solution number 3. Okay, so the given function for water usage is Wx equals to 500 plus 10x plus 0.2x power of 2. Okay, let's go through the steps again to verify and interpret the result. To get the first derivative, you have to write dw over dx equals to 10 plus 0.4x. Okay, now let's see how to set in the first derivative to 0. Given 10 plus 0.4x equals to negative 25. How to get negative 25? For the step 1, bring 10 to the other side, so it becomes negative 10. For the step 2, bring 0.4, so it becomes negative 10 over 0.4. So that's how you get the answer of negative 25. Okay, we are going to look for the second derivative. Given d power of 2w over dx power of 2 equals to 0.4. Since this is positive, so it indicates that the function has a minimum at x equals to negative 25. Since x represents the number of sessions per week and cannot be negative, we must consider the practical domain x more than or equal to 0. Okay, within the practical domain, we must evaluate the function wx at x equal to 0. Okay, let's confirm this. W0 equals to 500 plus 10.0 plus 0.20 power of 2 equals to 500. Therefore, the minimum value of Ws for x more than or equal to 0 is 500, occurring at x equals to 0. Okay, so the minimum water usage occurs at x equal to 0 session per week, yielding W0 equals to 500 liters. This implies that if there are no irrigation session, the water usage remains at 500 liters, likely representing a baseline or fixed component of water usage. So this baseline value could be due to factors such as unavoidable leak, essential water needs, or other fixed water usage components.
Hi, I'm member number 4. This is the solution for number 4. A farm uses water to irrigate crops and add water usage W in liter is given by the function W x in bracket equal 500 plus 20x plus 0.5 liter equal, where x is the number of irrigation sessions per week. However, the farmer must irrigate at least once a week. Determine the optimal number of irrigation sessions that minimize water usage. Binti 2 x more than or equal to x less than or equal to 5. My first derivative is dw over ds equal 20 plus s. Derivative to 0, 20 plus x equal 0, x equal negative 20. The second derivative test is d equal w over dx equal 1. Since d equal w over ds2, ds equal more than 0, the function has a minimum at x equal negative 20. Is given x more than or equal to, x less than or equal to 5, w in bracket 2 equal 500 plus 20 in bracket 2 plus 0.5 in bracket 2 equal 541 liter. The second one is w in bracket 5 equal 500 plus 20 in equal 5 plus 0.5 in bracket 5 equal 612.5 liter. X equal to w in bracket 2 equal to 541 liter. So the conclusion is the optimal number of irrigation is 2 per week, minimizing water usage to 541 liters.